Hi everyone. Today we're going to be working on IXL assignment HCW, Identify Graphs Word Problems. Now, of course, there's lots of different types of graphs, but what we're going to focus on here are function stories. So remember that when we're talking about a function, it is a relationship between two different things. We have an input and an output, and what makes something a function is there is a unique output for every single input. And when we're working with functions, we can often use them to create graphs like you see here. And typically, I like to call them function stories because it's a functional relationship and we're telling a different story. So if we look at the one on the left here, if we check out our labels, we can see our x-axis is measuring time, and then our y-axis is measuring elevation. And based on the picture and the labels, it looks like we are, telling a story here. We are tracking somebody's height, somebody's, hike up a mountain or, up a big hill. And so when we look at this, our flat lines here, we notice that time is continuing to march on, but our elevation isn't changing. That y value is staying consistent. So when we have a horizontal line, when we have a flat line here, we are, staying in place in this case. So, I mean, if it's based on elevation, we're walking, but it would be a solid path. It's not a hill or anything like that because we are not changing our elevation at all. But then this next segment here, when it increases, not only does time move on, but it also goes up along the y-axis. So that means we must be going up a hill. Our elevation is increasing, so we are going up. And then our next segment here, that's flatlined. Again, our elevation isn't changing. And then when we have sections that have a negative slope that decrease, in this case, it means our elevation is decreasing. So I must be going back down a hill because our elevation is now decreasing and it's getting closer and closer to zero. So there are just kind of some things to look for is when we have a positive slope, we're increasing, a negative slope, we're decreasing. And then when it's horizontal, when we have a slope of zero, that is something that is constant and it is not changing. And just one more example, we have time again for our x-axis, and then our y here is our heart rate. So it looks like this guy's working out. So we can see when he starts the workout, probably at a little bit of a jog here, his heart rate goes up a bit, but then he probably starts sprinting, going super fast. And so his heart rate, skyrockets. Then, it kind of flattens out here. So either, he settles back into a walk, or maybe, his heart just kind of stabilizes, but his heartbeat ends up staying consistent and being the same for that length of time. And then here it decreases. So this is probably his cool down. He's starting to slow down. He's starting to, go from that run to a jog to a walk, and his heartbeat is slowing down and getting more back into that normal rhythm. So this right here is what we're going to be doing on IXL is we're going to either be matching stories to graphs, or like we did here, having a graph and describing it and matching it to a story. So let's go ahead and hop on over to IXL now. All right, here we are on IXL assignment HCW, Identify Graphs Word Problems. So if just kind of looking at an overview here, it looks like we have a story that we need to read and we need to pick which one of these graphs is going to match it. All right, so Keenan is a sprinter on his school's track team. During a race, his breathing rate increases until it is much higher than his resting breathing rate. His breathing rate remains elevated until the race is over. Once the race is finished, Keenan's breathing rate gradually returns to normal. Which graph could show his breathing rate before, during, and after the race? All right, so with these, I always read it at least twice, maybe even 3 times. The first is just to kind of figure out what's going on. Then I'll read it again to see which matches it. So I can tell this is actually like the example we just did on my slide about running and your heart rate, or in this case, your breathing rate. So it says that he noticed that it increased. So that would be a line that goes up until it's much higher than his resting breathing rate. and it remained elevated. So it stayed consistent for a while. So that would be kind of a flat line until the race is over. And then after the race finished, it gradually returns to normal. So that means I would have a decrease, but it wouldn't be crazy steep. So when I look at that, it looks like this first one here matches it because his breathing rate increases and then it stays elevated and then it slowly goes back to normal once the race is over. The second one here doesn't have that middle piece. It's missing that part of it remaining elevated, of it having a constant, a flat line there. So our first choice here, our first graph, is the one that matches our scenario. All right, next up, Haley is giving her puppy a bath. She fills up the bathtub, washes the puppy, and then empties the bathtub. Which graph could show the amount of water in the bathtub over time? All right, so if we look at this, we have time and then amount of water. So she fills up the bathtub, so that means the water would increase. Well, when I look at both of these graphs, they both have a section that's increasing. That's a good sign. And then it says she washes the puppy. Well, as she washes the puppy, time is moving along, but you're not going to keep having the water running. That's a waste of water. So we're going to have a section that's a flat line because this is when she's washing the puppy, but that water level stays the same because she's filled it up however high she's going to fill it up. And then it says she empties the tub. Well, if we empty the tub, that water is going to drain. So I would need one that decreases, which means our first graph here matches this scenario. The second one then increases. So that would be like she added more water to the tub, but she didn't do that. She emptied it. It's going to go down to 0. So that's why this first one here is the better match. Next example, Garrett celebrated his 18th birthday by going skydiving. He jumped out of the plane and began to free fall. After a little while, he pulled the parachute cord and floated the rest of the way to the ground. Which graph could show Garrett's height above the ground over time? Okay, so it says he jumped out of the plane and began to free fall. And then after a little while, he pulled the parachute cord and then floated the rest of the way to the ground. All right, well, when we think about this, if he's jumping out of the plane and he's free falling, is that going to be gradual like we see here? Or is that going to be a pretty dramatic drop in height? That's going to be a pretty dramatic drop in height. When you're free falling, you're going pretty fast. It's going to drop pretty quickly. And then the second half, if I change my color up here, when he's floating to the ground, that's going to be pretty slow. He's going to really slow down and take his time. So this second graph is the better match. So sometimes when you have examples like we do here, you got to think a little bit about the scenario and have kind of some background knowledge to help you answer. So that free fall is going to be fast. It's a very steep slope, pretty dramatic. And then when he floats, it's going to take him some time to get to the ground. So the second one is our best match. And then last little tip that I want to give is notice how many times I read it, how many times I checked things. This is definitely not one you want to rush through. There's lots of pieces to look at. So just like I did after I made my choice, I kind of went back through and talked through it again to make sure it really is the right answer and really is the best choice. All right, we'll do a few more examples together because I know a lot of these problems are pretty different. So we'll do about 2 or 3 more here together today. So Trisha is biking to her friend's house. She starts off with a burst of speed, but the first half of the trip is on an incline, so she slows down gradually. Luckily, the second half of the trip is downhill, so Trisha picks up speed again before coasting steadily. Which graph could show Trisha's speed over time? All right, so she starts off with a burst of speed, pretty fast. But then it says the first half of the trip is an incline. So then she kind of starts to slow down. So when we look at both of these, I'd say both of these kind of show starting off quick because it starts off pretty high on the speed. But which one then shows that she slows down gradually? Well, it's kind of looking like it might be this one because it's slowly decreasing in speed, where this other one is increasing in speed, it's going up. And then it says the second half of the trip is downhill. So she picks up speed again. So now she's going downhill, which means she's actually going faster and faster. So her speed is up. And then it says she coasts steadily. So it kind of looks like right here is where she's starting to coast. So this first one is an appropriate match because it was focused on speed, not on distance. So that's why this is the better match. All right, once you get a little higher into the SMART scores, instead of just having 2 graphs to choose between, you may have 4 different ones. Even though you have more choices, the process is still the same. So let's go ahead and read it. At the petting zoo, Gabby watches a small goat as it plays on the goat playground. The goat runs in a circle on the ground, slowly climbs up the ramp to a low platform, takes a step up to a higher platform, prances around for a few moments, and then jumps back down to the ground. Which graph would show the height of the goat above the ground over time? All right, so that's key, is we are trying to figure out the height of the goat. So that's what we have to keep in mind as we find our graph that matches. So if it says the goat runs in a circle on the ground, that means it's on the ground, there is no height. So if we look at all 4 of our graphs here, they all have a flat line at the beginning. So that matches that goat just chilling on the ground, running in circles. Next up, it says it slowly climbs up to a ramp. So if it's slowly climbing, is that going to be a really steep increase or a gradual increase? It's going to be pretty gradual. If it's slowly, it's going to take a lot of time. So I'm definitely thinking that D down here is probably not it because look at how quickly we increased. So I'm thinking that one doesn't match. And then I'm not even sure if the third one matches. Well, I won't totally, count it out, but I'm thinking C here looks pretty steep. So I'm not too sure. I won't count it out yet, but it's not looking too good. But then the first two, that works pretty well. It seems like it's not super steep. It kind of takes a little while. I really honestly am liking this one for that part because that takes the longest. But we got to keep reading. The next part says, then the goat takes a step up to a higher platform and prances around for a few moments. Okay. Well, it takes a step up and then prances around. Well, this shows a step up. This shows a step up. This one does not show a step up. All right, we've now eliminated those two. And then it says he prances around. So that means his height would be staying the same. This one right here is the only one that shows him staying the same and prancing around. So even though I liked that increase, I don't like that one doesn't have it. So I think we found our winner, but let's still finish it off. And then it says he jumps back to the ground. So he decreases back to the ground. All right. A, this first one here is the one that fully and best matches our story. All right, this is the last example that we'll do together here. Jacob is the punter for the school's football team. During practice, he has a ball in his hand ready to punt. He drops the ball and then kicks it before it hits the ground. The ball flies through the air and lands farther down the field. Which graph could show the height of the football above the ground over time? All right, so if we look at this closely, we're wanting the height of the football above ground. So I got to keep that in mind. That's what we're tracking, is the height of the football. So it says he has the ball in his hand. So if his ball's in his hand, I don't know how tall he is. Maybe he's, say, 6 foot tall. Then that means the ball is going to be above the ground. So in looking at these, I would currently feel like A and C, because there's no numbers, A and C seem to be like a better measurement because it's kind of low to the ground, where the two starting off points for these two is pretty high up. That seems like that would be a really tall person. So I'm not going to count it out yet, but I'm not really liking the start of these two choices here, B and D. So I'm leaning more towards, here, let me label these so I don't say the wrong letters. I'm really leaning more towards A and C right now. Those seem to be better choices just because logically, guy could be short, guy could be tall, but it's probably a little bit lower to the ground in the scheme of things when you can kick a football crazy high in the air. All right, so what does he do after? The next step is he drops the ball and kicks it before it hits the ground. Okay, so the ball drops, but doesn't totally go to the ground. So here we have a nice little drop, but it doesn't hit the ground, so that works. C, we have a drop, but again, doesn't hit the ground. That works. B, it goes up even higher. That's not a drop, so that's definitely out. And then D, it technically has a drop. Again, I don't really like how it looks, but it technically works. Can't really eliminate that yet. All right. And so our next step is the ball flies through the air and then lands farther down the field. Well, if you're kicking a ball, it's going to go up in the air and then come back down. It's going to have that little arc. So I'm really liking A because it's not like it ever stops. That ball is just going to sail through the air and then come back down. Where C, we have a specific point here. That is a really crazy increase and decrease. That doesn't really match the natural, path of a ball if you're throwing it or kicking it. And then D definitely doesn't work because keeps kind of zooming around. And obviously, here's another thing that actually proves D doesn't work. That would be leads us to think it wouldn't. That means if this guy's standing right here, he must have been on a ledge because it dropped that far and then he kicked it up that far. Yeah, it's not going to fall that far. That would be a crazy, crazy tall person. So actually looking at this closer kind of confirms initial suspicions. D is not it. So our winner here is definitely A, because A shows us an appropriate height for a person. It drops down. And then this curve is a natural curve of you throwing a ball or kicking a ball where it gradually goes up and gradually comes down, where C is way too strict, way too, can't think of the right word, but it goes up and then to a point. But if we're looking at height, it's going to have more of that curve. That's more of the natural curve of things between height and between speed. So A is our best choice here. All right. So hopefully this video helped you out. It's really a lot of reading, a lot of trying to, pull from your background knowledge. So hopefully this helped. But of course, if you have any questions, reach out and I'll be happy to help. Bye.